Hi, and welcome to this video showing how to tune a QTouch design for optimal performance. This video assumes that you are familiar with setting up and configuring a touch project. So if you are uncertain how to do this, please take a look at the video tutorial named Getting Started with QTouch Composer for a full walkthrough of how to set up a touch project. As you can see, we have our system running, and key presses and sliders work as intended. So it definitely seems like the system is working well. But to make sure that it is indeed working at its full potential, there are a couple of easy things you can do. Atmel Composer has a great built-in feature that allows you to check out robustness of the sensor layout and wiring. It is called the Tuning Wizard, and will guide you through a number of tests, asking you to push buttons and sliders, while at the same time recording and analyzing all measured data from all touch sensors. This allows Atmel Composer to identify sensors that are mechanically not working as well as they should, and also suggest changes to software parameters to increase overall performance. So, let's see how this works. First of all, I will push the Show Signal Strength button. This tells QTouch Composer to show the raw delta values on the buttons. A brown dot means that there is a small signal present, but it has not yet reached the threshold of the button. Once the brown dot turns green, we have reached the threshold, and it is now regarded as a valid touch. Any further increase in value after this point is shown as a growing dark green dot. Press the Tuning Wizard button to launch the wizard. The wizard is quite self-explanatory, but let's take a closer look at how it works. The first thing you're asked to do is to leave all touch buttons untouched, and then do a reading on the system. This records all idle sensor values, and also measures any background noise present in the system. Push the Measure button, or the M key, to do the measurement. Once the measurement is done, the validation wizard will automatically continue to the next set of tests. Buttons are tested first. This design only has 2 buttons, but for systems with many buttons, it is very useful to test the performance of each button independently, and also measure how touching one button affects signal and noise levels on all sensors in the system. Follow the on-screen instructions and press each button when told. This allows QTouch Composer to identify any crosstalk or noise caused by the hand shadow or poor signal routing. Once all buttons are tested, we continue to test the slider. To test the slider, we are asked to press the middle point and both endpoints of the slider. This allows testing the absolute signal values and making sure that the linearity of the slider is good. We are also asked to do some sliding movement on the slider. A sliding movement results in a lighter touch than a fixed press, so it is very useful to do this measurement to make sure that the smaller signal values from the sensor are handled correctly. A similar approach is taken for the wheel. On the wheel, we press on the 4 positions as indicated. This allows QTouch Composer to check absolute signal readings of the sensor and also to determine the offset of the wheel. As you can see, if you press the 9 o'clock position, this does not align perfectly with the position shown by the virtual kit view in QTouch Composer. The reason is that the 0 position of the wheel is determined by the physical layout and orientation of the wheel on the PCB. Again, we do a measurement on the sensor while doing some real rounds on the wheel. This time, we do both directions just to give more input data to QTouch Composer and get better average readings. When the wheel is done, the next thing that will come up is the Summary of Measurement screen. This is a report card of the performance achieved during this test. Green means very good readings. Yellow is still good, but indicates that there are potential improvements to be made. Red means that it may work, but you should definitely have a look at it and try to improve the performance. In this test, we are using a capacitive stylus that will reduce the signal readings to show you how weak signals are shown in the Design Validation Wizard. But the Design Validator goes even further. It will display recommended parameter changes, and in cases where physical changes are recommended, it will highlight and describe what to look for. Here, you can see that SNR is displayed in yellow, and the minimum delta reference is too small. This can be fixed by tuning parameters and components. As you can see, the buttons 0 and 1 are still giving good results. It is only a matter of tuning the delta and reference slightly to make it perfect. The readings we have on the slider is suffering a bit more, where we can see that the crosstalk is a bit too high. This can be corrected by using the AKS function of the QTouch library. On the bottom of the page, you can see the recommended settings, where red means that the value is recommended for change. You can see that Library is not actually recommending AKS setting for the slider, but solves crosstalk issues by assigning an AKS group to the wheel instead, as shown on the next screen. If you wish to use the new recommended settings, updating your project with the new values is as easy as pushing the Write to Project button. QTouch Composer will then update your project settings with the new values. You can even test out the settings without recompiling the project by pushing the Write to Kit button. This will upload the new parameters to the touch device runtime and allow you to test if you are happy with the new performance. This concludes the tutorial on how to tune your design for optimal performance in QTouch Composer. Thanks for watching the video and using Atmel Touch Solutions.